Shall we kick it off? All right. Thank you, everybody. Welcome to our InterSystems winner webinar for our latest programming contest, our Grand Prix contest. For those of you who might not be familiar, we are InterSystems. We have a powerful data platform that can be used in a variety of industries. And we regularly have exciting programming contests roughly every 2 months with a lot of cash prizes. This is the winners webinar for our Grand Prix contest. It is our biggest prize money contest every year. We hold it every year around this time. There are over $26,000 in prizes. And this is our chance to celebrate the winners and to see some quick demos. Let me just pull up the winners page here. This is our winners page that you can find on our developer community. It also has all of the links to the applications that were submitted. They're all open source, so you can access them yourselves and look through all the details. We were extremely excited by this competition this year. We had over 20 applications submitted. We had some of the regular engaged people in our developer community contribute, but we were also very excited that we had 5 newcomers who had never participated in an InterSystems programming contest, and we welcome those and we invite others to try our contests as well. And certainly an interesting note is the number of projects this year that connected generative AI to our technology, InterSystems Iris. There were 10 submitted applications that leverage generative AI and InterSystems data platform technology. So that was absolutely fascinating. Let me just stop briefly here and ask if there are any of our InterSystems product managers and experts that want to briefly comment on the submissions this year. Maybe Tom Dyer?
Yes, I guess I would say that underline what Dean was saying was that we're very excited by all of the creativity we saw around generative AI. It's an area that we are very interested as InterSystems in pursuing some different product directions and getting an idea of what these things can do, these large language models and other generative AI kind of artifacts can do, and how we can unleash some new capabilities by combining them with our first-in-class kind of database performance and other capabilities that we have, and then modifying our capabilities to meet the moment and meet this new programming paradigm. Essentially, we could be seeing development being done very differently in the next, even in a year from now, to where you look at this large language model as the thing to be programmed with your prompt engineering and kind of centralizing around these things. So it's going to be a very exciting time. It's going to touch everybody in this webinar and everybody in the world, really, over as we're just seeing the beginnings of some real new capabilities coming online. So it's an exciting time, and very happy that you guys can contribute to our understanding of it and our direction forward. So looking forward. Thanks.
Thank you, Tom. Couldn't agree more. Any other InterSystems staff want to say anything? Just open it up briefly. All right, then let's dive into the demos. We are excited to see these. We'll start with the 5th place demo and move ourselves up to 1st place. I do want to just alert everyone that we do need to restrict the demos to 5 minutes because we have several and we would run past our allocated time if people go over. So please try to keep it to 5 minutes, and Evgeny is going to help me call out if people are going over because we do have to manage the time. So let's kick it off. And
Yes.
if Ikram or Sowmiya can demo Fire AI and OpenAI chain app.
Thank you, Dean. Just before Ikram getting ready, so you also are very welcome to introduce yourself, what you do, where you're from, like a short bio, but again, you have 5 minutes to speak about yourself and make your demo. Please go ahead.
Sure. So first I'll go. So I'm Ikram Shah, currently doing my graduate studies at Carnegie Mellon. So I got to know about InterSystems through MIT Grant Hacking Medicine. And from there, I'm in CMU, like there was an opportunity called Generative AI Innovation Incubator. So there, one of the healthcare projects I started working on, that's how I got more into FHAR. Then I came across this contest and I thought, okay, here's like another opportunity to take part on building something innovative. So I, along with my friend Sowmiya, we participated in this. Sowmiya, do you want to go on your intro?
Yep, sure. Hi, I'm Sowmiya. I am a friend of Ikram, and then we've participated in a few hackathons earlier. So I work as a software engineer at Google for the Fitbit teams at Warsaw. So that's sort of my interest, like, I mean, my alignment towards healthcare, but I've not worked on anything specific for like more aligned to healthcare, I'd say. So I've heard about FHIR and HL7 and all of these different things. So I wanted to try and see what these things are, and that this was a good chance for me to get into it. So that's my intro.
Great. Please show us what you did.
Sure. Let's share my screen and play a video. So this does not have any audio, so
We cannot hear it. It's no audio.
there's no audio.
Maybe you could comment what is going on.
Yeah, sure. So firstly, when we enter the application, we ask for an OpenAI key, and then we get the FHIR API-based URL. And what we are doing is we are parsing the API documentation, that is OpenAPI specification, into the OpenAI, and then we get the all paths and methods, what all APIs are there, we get that. And from that, the user can choose which path and method they want the input to go to. And on top of that, they write the query. Like if it is patient ID and get, they write, they can ask any kind of questions to that particular API. Which city is the patient ID one from? Then what the API chain does is it creates a query and calls the API, and then gets the response, convert that to a natural language, and then returns it to the console. So in this way, we can provide input in a natural language way, and internally it calls the API and then converts it back to the natural language and then returns it. So similar to this, we can chain in multiple endpoints and then try to build a solutions on top of that. Say patient ID and observation we can combine, and then the doctor can ask like, okay, when did the patient had a blood pressure spike in last 5 days or something of that sort.
Very cool. Thank you so much. Any questions from the group?
Yes, I have a question. This is Luca. Are you able to reference the API only by ID, or could you say, or could you like group things, you know, and write, you know, a wider selection of like imagine an SQL query where actually, go through a group of patients. I'm trying to understand behind it if you have some kind of a grouping ability, if there's a point-to-point, patient-to-patient only kind of query so far.
Okay, thanks for the question. So I haven't tried out the specific API where we can send multiple patient IDs or input, but if the API is able to support multiple IDs, then we can pass multiple IDs as input through the natural language query, and it does convert it to the specific API and calls it.
Thank you.
And Ikram and Sowmiya, do you have any ideas for how you might extend this application in the future?
So one thought which we were thinking about is like how we are using Postman kind of API management tool currently to just play around, to just check our REST APIs, right? So same way, how can we modify this particular application into API testing, like in a natural language way? How can people play around different LLM providers like OpenAI or Anthropic Claude or any kind of providers? How can they test in a natural language way and integrate? Because one main concern which we saw was like people were hesitant to connect their company's authoritative database to OpenAI kind of thing. So if they have the API layer in between, then it can be more authentic because it has the validations already in place.
Like it, and you're correct in that I'm hearing the same things about people hesitant to connect their data into these large language models. So yes, very interesting. Thank you so much. All right, and again, as Anastasia said in the chat, welcome to our community. Really appreciate you joining, and congratulations. All right, next up is Dmitry with Z Profile application.
Hello, everyone. I'm Dmitry Maslennikov, co-founder of company CareDev, developer community moderator, and so on, so on. So let's go to my application. So what the story behind the profile is, it's about to understand what's going on with the code if you have some performance issues. So like at this moment, we have like most powerful thing you could use is the MonoLBL, which will produce kind of like quite a big file with a lot of lines, a lot of numbers. Yeah, you probably can make it a bit look better, like when I hidden multiple columns, but it's still quite difficult to see the whole picture, how it's happened, the execution happened to be in this particular line, why it's what's happening here, and so on and so on. So I decided to build a project named it Z Profile, and I added some UI for it. So what does it do? So yeah, unfortunately, it limited to terminal due to limitation of the commands it uses. So it uses ZBreak with tracing ability. So what it executes, it uses ZBreak with break line by line. For each line, it collects all the metrics, and it sends to background process which take care about storing it, building tree of execution. So yeah, it collects time, all the metrics, which is also from MonoLBL stuff. So but it builds the tree, which then we can use, like go here, like this is the first level of execution. We see that it's a grand total of for each column. So like we can see that some global kills, global references, global sets, and so on in total time. For each cell in this table, it measures percent of from grand total and displays it as a this background, or also shows in numeric value. So we can easily find which line executed have bigger value. So we can easily go to this line. So I have this arrow button. So we can dive and see that it's still most of the execution is somewhere. So, but at this point, we see that few global reference happen here, and it's like 7% of time spent on this line. Then, okay, some part of time spent here, more glow kills here. And so we now can understand more what's happening in the code. So for now, we see that most of the execution is happening here, but glow kills already not so much. So it happened somewhere else. And another thing is that, like, okay, it's your code, you understand it, and you found the place where you wish to optimize, you execute it another time, and you can compare between execution on the same stack level. So it will be easier to see the difference. So I think that's it.
Excellent. Nice job, Dmitry. Congratulations again for winning. It looks like a very
demo online available, so anyone can see it kind of with pre-populated data. So I ran it and just download it, but play, see, yeah.
very cool. Any comments or questions from the group online?
Yeah, so hey Dmitry, it's Bob.
Yep.
I was excited when I saw this, and I said, "Oh, this is exactly what we want." But then you didn't connect it up with OpenTelemetry or the Open Tracing standard. You kind of built your own homegrown tool out of it. What was the thought process there?
It's just because InterSystems doesn't have anything like that. So I needed to use what InterSystems offer and to make it at least some way. Yeah, I thought to make it some more useful. So I didn't know about, so you mentioned open tracing. I didn't know about this. From what I remember, like in my experience, it like from Google Chrome, where you can have here like performance recording. Where is it? Performance here, and it shows some graphs. How execution. I wanted to build something like that, but I just didn't manage. I spent too much time already on this, even just to make this, because it was quite tricky to make it not too much slow. Even like so, like for this execution, so it shows it executed in like 180 seconds, but without tracer, it less than 1 second. So it's still too much. And yeah, it's just to find the balance between to not make it even worse than you have. So it's very difficult. But yeah, I still am thinking how to make it in some different format, so it can be used different tools. Yeah.
All right, thanks.
So we can, so we can hope maybe this feature will be introduced in the future. Yeah.
Yeah, extended. Yeah,
Okay.
I hope.
Awesome. Thank you so much. All right, moving on, Muhammad for Iris Chat GPT.
Yeah, hi all.
Yes.
Yeah, this is Muhammad Waseem. I am DC moderator and currently I'm working here in Jeddah, Saudi Arabia as a HAS manager. So let me share my screen. Okay, so this is my application, IRS Chat GPT. First of all, thanks to the community to introduce me to the LangChain. So during this contest, I just heard about it and then I done my study and then build this application. So just a quick overview, basically how this application is working. Actually, this is the application and it's connecting to the database to get the data. And also it can able to connect to the LangChain SQL and OpenAI as well. So it's also contain the Streamlit application, web application to just use the same code we can use there as well. So these are actually the InterSystem object script reference. So this PDF is saved in a ChromaDB in the vector database, and it's in the repository as well. If I go to the this is a repository basically. So in the data, it's already here the vector deb in the. So this is a file basically. It's already PDF converted to the vector database and saved in the database. So then what I'm doing, just I'm connecting to this database and just using the LangChain to retrieve all these details, to doing chat with the InterSystem object reference. This is all. So this all book, basically we can chat all these details. So same I did only this. This is I did by the document file. Just created one document file for contest and just run save in vector database. And then this is a Fire SQL builder. Chat GPT. I just used this SQL builder to generate all these tables. Then I'm communicating with these tables to generate this. So API key we already knows, thanks to other applications already explained. So basically I'm using here class IRS Chat GPT. This is a main class. So here I'm using embedded Python code. So this is the class mainly. IRS Chat GPT. So here I'm using embedded Python. This is a class, and this is just here I'm setting the API key. I'm using this global to set, and this is how setting the Fire server, the URL, and this is how calling the OpenAI. So what's this doing? Basically, here I'm using the Python here language. So exporting these libraries, LangChain, chat OpenAI, and this conversation, and then template, and this is IRS to just get this API key using this model, and then just here I'm just connecting here by passing these parameters and getting back the result. So and displaying there. And in case of IRS DB, so I'm using SQL database chain, so it's connecting to the IRS database and getting the information. So these are the parameters we can modify based on our need. So this is the ingest function. This is saving the vector database to the vector database. So it's taking the file, and then it's we are assigning the API key, and this is then is using embedding to make the binary files. Then we are opening the file, and then at the end we are just loading this one, and here we are saving this one. vector DB process. So it will save in the folder. And then this is the Iris docs. Basically, I'm calling to chat with the Iris documentations. So what is doing is again using this database vector stores and read the data and just do the chatting. And some other tools. So we can generate our own personal GPT and Wikipedia. We can chat with them. This DuckDuckGo, and this Python Perl to generate some code, Python code, and Iris Fire SQL. So it's reading all the table and generating the chat for it. So just a quick demo. So it's already. So I'm creating the new this already. I set the API key in the global, and then I'm just creating the new class instance, and then just here I'm calling the function for this class. So enter. So I'm asking, give me detail of this function, piece function. So it will just now it's calculating and will give me the result. So this is the result, the syntax of this. So these are all the details. So by same way, I can do other tasks as well. For example, this Grand Prix, just copy this command. I can just paste here. So give me prizes and nominations for this contest. So it will just say expert nominations, all are the details. So in this way, we can have another chat so this is by the SQL builder. So we can just take all that table and we can say, give me the total patients. So this is, we are doing chat with our SQL server with their database. So let me just, so it's just starting the chain, and then it will check all the query, and it's saying, okay, the total, there are 7 patients in we have. So same way we can just take all the observations, all the procedures, details like this. So this is all the details here already. So this is with the Fire server. Also, we can chat directly to the Fire server without SQL builder. All we need is to just set up the endpoint, and then we can chat. Give me total patients. So it will give the total patients. List down all the male patients. So it will list down all the male patients. We have ID 1 and 75. And give me observation of particular patient. So it will list down all the observation by using this lang chain, making the chain and all these details. And same, give me the procedures. So it will list down all the procedure for this patient. And give me all the immunization for patients. So it will get all the immunization. And then Iris Fire, give me the encounters, all the encounters for year 2012. So it will list down. So these are all. And then we can also communicate to Iris directly. Can just say, give me the total table. So it will just take all the table for information schema table. So we don't need to tell him exactly which table. So it automatically, it will get the table and retrieve all these details. So just let me try this one. So I'm asking, give me the total tables. So automatically it will take this table and just give me the result that there's a 998 tables in Iris database. So same way we can just do chat with OpenAI. We can use another techniques as well. And at the end, we have this Streamlit web application. So it's already running here. So this is the application. So we can ask different questions. So I already asked this question, and same with the other as Grand Prix at personal chat GPT, we can get it here. So all we need is to just browse and just select the PDF files. And after that, when we process, so it will just create the database, and then we can chat to that PDF as well. Same way we can chat with the document or CSV file and others as well.
Very cool.
So that's it.
Thank you so much, Mohammed. Very, very interesting, for sure. Any comments, questions from the group?
As Alex here, I just broadsided with all of these different directions that you've achieved. What was on your next list of, because there's so many sort of ideas you've explored with this project. Did you have any others that you're now looking forward to do?
Yeah, actually, I tried to build the database from the ideas portal as well. I already did it, but I was not just included here. And also for all our articles, we can just create a vector database. So I had these kind of ideas. So it's any vast field. We can do a lot of things as well. Thank you.
Thank you, Mohammed. Maybe we will follow up and we could add this functionality online to developer ecosystem services.
Yeah, sure. Thank you.
Thank you so much. All right, moving on. Let's bring back Ikram and Sowmiya for Iris Fire Transcribe Summarize Export app.
Yep, I think I'll take the chance to demo this time. Let me try sharing my screen. Can you guys see my screen?
Yep.
Cool. Yep, I'll walk through the demo first and then maybe go over the folder structure a little bit and then wrap it up. So I'm just giving a little bit of a brief before we jump into the video. So our goal was to try and simplify all the different touch points that a clinician has to sort of go through when they're trying to work with documents in the context of FHIR itself also. So when they try to create documents, when they try to search, view, retrieve, the different stages in which they might have to interact with documents in like at their workplaces. So I'll start with the demo now. Yeah, the first step is when they try to get the patient, and then they just go through all the different like patient information that's already available to them. And we have ways to search for encounters, the previous visits, and then look through the documents that has already been created for this patient. And here, for instance, they can also view the PDF file of the document, which so the front end that you're seeing right now, it's a Vue.js app which Ikram coded end to end. So it's from scratch, and he built all the views. So he's also built this module where you can export the documents to PDF, and it's also downloadable from there. And moving on. Now I can't really play the audio here because I think it might not work on Zoom, but when the recording is going on, like we have an audio playing where a clinician might be trying to record their like transcript of what happened during an encounter when they met with the patient, or live during the patient is speaking, a recording might also be possible. And the goal is to summarize and create a title automatically for this conversation and then store it into FHIR. So that's what we'll see in a few seconds. Maybe I'll just fast forward. And yeah, so we can see the transcript here, the summary and the title that it created. So this was a conversation about an H. pylori infection that the subject had, and the summary has also so for this is where we use OpenAI. We use two different APIs. One is the Whisper API, which is basically to convert audio to text. It's much more accurate than normal audio processing APIs that were existing before Whisper, for instance, because it can work with natural voices much better. And the second API is to convert the transcript to a summary, which again we use the text completion APIs, which normally we know as GPT today, and it summarizes the transcript to a shorter form, or in a more, I think it just tries to summarize the longer conversations better. So and after this, this is where the documents get created, and then it's listed. And the next step is we wanted to try and integrate with Google to export the document to Google Docs, because that might be a better way to share with other, other clinicians or with the patient themselves directly. So the first step is to log in using OAuth to get the credentials to export the doc. And then you click on the doc icon on one of these documents, and then it creates a document for you. And clicking on the doc takes you to the document itself. And the sharing is much easier because you can add users. And it's also only created and shared to the person who's creating it. So it's not available to the access is more fine-grained. And also because we'd already done docs, we also thought maybe the observations can also be exported to Google Sheets. So we're exporting the observations here to Google Sheets. Which is again a similar works in a similar manner, except the API is a little different to export data versus text. So this is the feature related to the export. And the final, I think this is also another aspect. The search aspect on the documents is very. I think it's solved in a elegant manner with LangChain and OpenAI in the backend. Because I think this is where the power of AI really comes in, because it can semantically search through documents much better than the normal text search that we have. For example, here, if we created multiple documents for this patient, because with like clinical notes mimicking symptoms of gastritis, and here if they pull up the history of bloating, it summarizes what across 3 different documents what the patient had symptoms related to bloating. So so doctors can pull up without having to search through different documents to like correlate the symptoms. They can ask the search for an initial sort of summary, and then maybe look into the source documents here in detail. So this we solved using techniques similar to what Mohammed earlier showed. We used Chroma to index the documents into the vector DB, and then we used the text completion OpenAI APIs to use chunks of these index data to look through the documents. And also we used source-based search so that we can list back the sources, so that you can click on them and then view the source itself, the overall source itself. So I think that pretty much sums up the demo, and this was our repo. We had a Vue front-end app, like I said, which Ikram worked on pretty much end-to-end, and he built a lot of the components from scratch. And this helped us, I mean, build more, I think, specific UI to our use case. And then we had an embedded Python module. This I should again thank Mohammed, because he had posted a template earlier to use embedded Python with REST APIs and all of that. So this was very helpful because both of us were new to InterSystems and object scripts. So this was helpful for us to build our solution. And so this has the code to connect to OpenAI, to all the different clients that we have, all the different downstream services that we have. And I think, and we also have the Fire server running in the background to host all of this data. So you can take a look at us at our repo or the video and reach out to us if you need any information. So that's all from me.
Very cool. Thank you very much, Sowmiya.
Yep.
Any questions or comments from the group?
Yeah, I was just going to ask, this is great. Was there anything, or what was the hardest part for you in terms of building this or finding things to build this with?
I'd say for us, maybe it's because both of us are new to InterSystems. I think initially playing with the templates and sort of figuring out how the InterSystems itself worked was took us a little while. But once I think we had nailed that, we could like build things on top very easily. Because I think Fire and all the different Docker templates that we had was really useful. Apart from that, maybe with the OAuth for Google, that's a little tricky. There's been a bit of changes to the way identity works now with Google Docs and Sheets, so that I think it was a little complicated. But in general, I'd say OpenAI and all their APIs are pretty user friendly, and it's not that hard to build on top of them. Yeah.
Great, thanks.
Any other comments, questions? All right, moving on to our first place winner, Jose and team.
Hi guys, let's share my screen. Okay, here's my screen.
Yeah, we see it.
Oh, thank you. So I will talk about actually is an kind of experiment. It's not actually in a graduate use application. So we call IRIS-Fire generative AI, which is experiment of using generative AIs to build a link between Fire, between a question in health domain, and using Fire and Python to answer this kind of questions. So here is our team. Just unfortunately, it's just me, José, Henrique, and Henry. So about the project idea. So this idea comes when I saw an article about a guy with a very cool project when he used voice comments to use ChatGPT to translate voice comments into argument reality functions to AR library, and the very cool application where the guy points out the smartphone to a table and said, okay, put a frog on the table, and the frog comes from like magic. So I'm very interested into this code, and I get the GitHub and discovered a thing called prompt engineering. And also this was a few months ago, and also I heard a lot about privacy concerns about exposing data to the external servers like Open API, and combining those ideas, I'm kind of start to think, well, what about to use Fire in order to not expose data or schema or private schema like SQL schemas, and Python, using Fire to as a common interface to get information, health information, and use Python to manipulate this data and get the answer for an analytical question. So so this was the first idea comes to my mind. So it's like I said, the user do a prompt. This prompt gives some kind of enhancement, which is called prompt engineering. This prompt was sent to OpenAI. OpenAI, in a magical way, translate this to Fire and Python and come back to Iris. So using embed Python, we execute this code. This code request do some communication with the Fire server, get the data, process, and present the result to user. But as I said here, this is a hack path. So there's a lot of pros and challenges in this kind of approach. So the pros is the flexibility to answer questions that our analytical model are not yet ready to answer. Also, we could get all kind of user questions logged for further analysis and insight, exploration. Also, as I said, we don't have to expose any data and local data or schemas to external servers. But also we have a lot of challenges. First, how to instruct the generative AI in order to correctly use Fire and Python. Also, how can we assure about accuracy of those questions? And of course, executing a code generated externally, mainly using a very powerful language as Python, of course is a security issue, the security concern. So how can we deal with that? So there's a lot of questions come to mind, and we decide, okay, instead of presenting a ready-to-use application, why not presenting an experiment in order to discuss this pros and challenges? So this is a pause after this trade-off. We refined the original design, so, and we added something which is mainly a code analyzer for Python, in order to try to be aware for security issues. And also we thought in a very important feature, which is log all kind of events that the system have in order to understand why it is happening. Because as Tom said, this is kind of new program paradigm, right? So it's very new, and we need as much information as we could record for this black box that is generative AI, all right? So I present a very quick demo. There is not so much new to present. I think what our colleagues presented was more than I can to show you there, but let's show you quickly. So here's just a simple question asking how much patience we have in our file server. So the result is the number of patients, of course, and explanation of what the generative AI, the path that the generative AI takes to answer that. And here we can see all kind of events that we log in our database. So we log the prompt, what the OpenAI returned to us. Also, we extract the code. We present the code to the secret linter, get the results. This kind was where there was not secret issues. So we are able to execute the Python code and present the response to the user. We also have a very simple chat interface here. It's just the same because we have turned it available as an API. So we have the same output here, just in chat presentation. So again, let's come back to the presentation. So what I want to focus here is what is happening behind the scenes. So first, I would like to talk the prompt engineering. So this is just a fragment of the prompt engineering. You could see all the instructions in the GitHub, but I would like to point out some techniques from prompt engineering that I read and used here. So the first one is the role assignment. It's always a good idea starting your prompt by saying to the generative AI, to the LLM, what kind of role it had to assume. So in this case, we say, okay, you are a data analyst, which knows the help domain and knows Fire, knows Python. You are going to use those elements to answer analytical questions. And also, follow this first, the role assignment. There are a bunch of code constraints. So this one is a constraint to create common point to call the generate code by AI. So I said, okay, you can create all kind of code you want, but the result must be obtained using by a function called I remember get answer the function. And also I try to avoid the generative AI to create any kind of HTTP request to external source. Another interesting point here is the generative AI gives a lot of bad request calls because it created a wrong fire call. So here's some examples that what is wrong and what is right. So this is another prompt engineer technique which you present examples to guide the AI. And last, what I'm expecting as the return. As I expecting to get Python code, I decide to use the C data block for XML in order to facilitate the stuffs like Python code indentation. So I'm use another technique for prompt engineering that specify what you want to give using an example. And here is an response example. So as you can see, I got the fire code here, the Python code here, calling another thing that I forgot to mention. As I'm said to do not create HTTP calls. I must provide some way to grab information through fire. So I said, okay, in order to get fire information, you use a function called fire, and the AI was able to understand that. As you can see here, it creates a path, fire path here, and presents you the call fire function. And also in the function as I'm requested was a function called getAnswer. And also I'm instructed to give me some quick explanation of what path it took to give me the answer. In order to analyze the Python code for security issues, we used a Python library called Bandit. Very nice. This very nice library. It creates a abstract search tree of the code and look for security issues based on CWE. Here is an example of a non-malicious code, just a simple code to query fire resource, and the result of the result property of the Bandit output is empty array. But I'm in this example, I'm append to the code a malicious code where I'm trying to I try to access an external API from the local environment, and as you can see here, Bandit was able to detect the vulnerability in the result property here. So in this case, the system stops the execution and log a security error log. Yeah, this is an error to guide me. Okay, and also another important thing is about tests. So as I said, I'm concerned about accuracy and security. For accuracy, I create SQL statements to query resource in order to get the expected answer. And for security, I use the Bandit library as said. For accuracy, I got this result. We got I'm asked for prompt for ChatGPT to create prompts increasing the complexity, and as tried each of those questions a few times, and getting the average, we see that for accuracy, we have a trend to decrease the accuracy. And at the same time, we see a trend to increase the execution error. So as expected, as we increase the complexity, the generative AI starts to fail. Oh, yeah, that's a balloon to guide me.
Jose, we're moving to the end of our session, so
yeah,
we need to wrap it up. Yeah. So if you maybe want to say some final conclusion.
Yeah. This is as I said, for security, all cases was detected. For log, we log JSON, and so in order to better understand, we use to grab the concepts and create dashboards in order to get insights. So here we see the patient was the top topic is, and also for the execution error, we got a lot of bad requests. So this was assumed to improve our prompts. So yeah, I think that's it.
Very cool. Awesome work. Any questions or comments from the group? All right. Thank you all so much. We really appreciate all the submissions. Your innovative work is exactly why we actually do these programming contests regularly. Thank you all very much. We will be announcing the next programming contest soon. Please check it out and please invite your friends and colleagues to try it as well. Thank you all very much for attending. Appreciate all your work and congratulations to all the winners. Thank you.
Okay, thank you all. Thank you.
Congratulations. Thank you.